And done. Oh, question 3. I would like everyone's contribution here. Here we go. Keep it for you again. Question 3. Warm aqueous solutions of ammonium chloride and sodium nitrite react according to the following equation. Okay lah. So they give me equation, so I don't need to have this anymore. Right? The first one. Good. Which of the following variables, 1, 2, 3, or 4, can be used to monitor the rate of reaction? Okay, so ladies and gentlemen, what is this? Rate of reaction. Remember my first 5 minutes of the topic? What is rate? So this question is asking us this. Rate is change in something over change in time. So ladies and gentlemen, time uses a stopwatch. Nothing to discuss. Everyone know a stopwatch. So the question is asking you which of the following variables, 1, 2, 3, or 4, are here is trackable, observable, such that you can press your stopwatch, start, and then end it. That is the question they are asking. Okay? So that we can discuss their rate itself. Okay. So in the exam, what would I do? Again, I'll be looking at elimination process. First of all, which is here. Number 1, can this be the answer? Color of the solution. This is again a short question. 4 students say something. Who is correct? Who is wrong? Explain. Okay? Can or cannot? Cannot. Right? Tell me why. They're all colorless. All ammonium salt solutions are colorless. All sodium salt solution are colorless solution. The reactants are colorless. At the end, you get a product salt called sodium chloride. It's also colorless. A gas will fly away and it's a colorless gas. You cannot see anything. All right. And water, again, is colorless. So from the start to the end, you look into the beaker or conical flask or whatever container, the color did not change. It remains colorless from start to the end. Congratulations, 1 is wrong. And therefore, anything that's 1, you strike it away. That's the first step, elimination process. Again, no such thing as careless mistake. I don't believe in careless, unless it's pressing a calculator. Finger too fat or too thin, didn't press correctly. Elsewhere, got careless. Number 2, volume of the gas produced. Obviously, we talk about this. There is a gas here. We can measure using a gas syringe, correct? And then we can track the amount of gas. So number 2 is good. So every time I have a number 2, I will think it's the answer. At the moment, it doesn't help us at all. That's how we get full marks. Next, number 3, mass of the reaction mixture. Once again, if there is a gas, it will fly away, and therefore the reaction mixture mass will drop. Correct? We have discussed this in the notes. So it will drop. So here we go, and this will therefore be the answer, correct? So let me just write it down. I think this is good. The reaction, reaction flux, mass of reaction flux, right? Let me be more precise. Mass of reaction mixture, actually the same, right? Reaction flux, reaction mixture. All right. It will decreases. So this one decreases. Sorry, just now all of your answer is what? So number 3 also okay. Okay, wait, let me write this one. So number 3 okay. Number 3 okay. I start to eliminate again. I'm left with A and D. Yes. Just now your answer was what? Okay. On 18 plus 1, 19, right? There's more than that number. Some people never resend, is it? So all D, right? All A, right? So we have last one. Because you haven't solved it. So either you're good or you suck. In red. Number 4. Conductivity of the reaction mix. Sure. Oh, you're good. Ladies and gentlemen, in a reaction mixture, talking about conductivity. In chemistry, we talk about what conductivity? Electrical. Physics student, you got electrical, you got heat conductivity. In chemistry, only about electrical conductivity. The reaction mixture is what kind of mixture? What's inside that container? Aqueous solution, right? So electrical conductivity in solution or aqueous solution is based on which keywords? Mobile charge ion is a lousy word. I always tell you. Mobile charge carrier, you say mobile charge carrier or mobile charge ions? Mobile charge carrier is the no need to write one by right. It's either mobile charge or mobile ions or mobile electrons, which acts as mobile charge carrier. I repeat myself. Either someone teach you wrongly or you listen wrongly. It's not the keyword. The keyword is the earlier one. Ladies and gentlemen, in a solution, do you have mobile electrons? You only have mobile ions. And the mobile ion acts as, copy this down, charge carriers or mobile charge carrier. The new approved textbook also write this, which I'm not very happy also. And they make a few errors already. This is not an error, but I don't think this is necessary. But they did write mobile ions first. Copy this down. Don't write mobile charge carrier. The charge carrier is very vague. Because it can be ions, it could be electrons. I.e., you never give them the keywords. It's not a keyword per se. Understand? The keywords represent the concepts, which is the story. But we haven't solved it. That doesn't mean this is the answer. So you might be still all correct, 19 of you. So, hello, everyone, ready? So where can we find the ions? Yes? Let me write it out for you. I got NH4 plus ion. I got Cl minus ion. I got Na plus ion. I got NO2 minus ion. Before and after. The right side, I have Na plus ion. I have Cl minus ion. Ladies and gentlemen, is the number of ions left side and right side the same or different? Congratulations, everyone. Every one of you has been slaughtered in this question. So this is what we call application using an MCQ. You cannot memorize, you have to think. Can I run? Correct or not? Make sense? At the start, I got a lot because it's ratio of 4 to 2. Then later, the 4 there getting lesser, the 2 there more. But the up and down are different because the ratio is different. Make sense? Ladies and gentlemen, answer is option D. Slowly, I'll give you a minute to absorb, right? And write whatever you want to write. Answer is option D. Yes. Good. Then someone asked, which I'm waiting for the question. Clarence, very good. Doesn't water also conduct? Let's talk about water. Where do we learn water? We learn it in ABS also. Let's use a different color here. Can I have a different color? Dark green. Water is not aqueous. Water is what? It's a liquid. Water, what do we learn about water? Water only partially dissociate in water. Dissociate in water. You only partially dissociate. The reversible arrow that you learn in ABS tells you that the amount of ions here is very, very low. Low concentration, low amount. Very, very tiny. As good as close to negligible. That's why we say pure water, you won't get killed, won't get electrocuted. Remember? Because the H plus OH minus is so little, it doesn't conduct electricity that well. It does conduct very, so it won't die. Using distilled water, pure water. Parents, hope that answers your question. Okay, good. If you would like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you would like to join my live chemistry classes and revision workshops,
go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.